In this video, we're going to take a look at finding the prime factors of a number. So every number has its own unique prime factorization, and we can easily find the prime factorization for a number by using a prime factor tree. So for a prime factor tree here, what we do is we take the number that we're working with, in this case it's 40, we put that at the top of the tree here, and what we do now is we place two branches here from this number. So one branch to the left and then one branch to the right here. And what I need now is a factor pair here for 40. In other words, two numbers here that I can times together to get 40. Now because 40 here is an even number, in that case I can just divide it by 2. I've got 2 here, and what do I times 2 by to get 40? Well, that must be 20. We get 2 and 20 here. And what I do from here now is I check both of these numbers here and check whether they're prime numbers. Well, 2 is a prime number, it's only divisible by 1 and itself, so we circle any prime numbers here. We circle 2, but 20 here, that can't be prime, it's an even number, and it's not 2, so in that case we do 2 more branches here from this number. So one branch to the left again, and then one branch to the right. And again, what we need now is a factor pair here for 20. And again, because 20 is even here, I'm just going to divide it by 2. I get 2 and 10 here. And again, what I do now is I just check whether these numbers here are prime. Well, obviously 2 is prime, we've already circled that, so we'll circle it again. But 10 here, again, that's an even number, so it can't be prime here because the only even prime number is 2. So now we do 2 more branches here from 10. And again, we need another factor pair here for 10. So again, because 10 is even, I'm just going to divide it by 2. I get 2 and 5 there. And then finally here, we just check whether these numbers here are prime. Well, 2 is prime, we've already circled that here and here. We'll circle it again. And then for 5 here, well, 5 is also prime, it's only divisible by 1 in itself, so we circle that here. And once you get to the point now where you can't do any more branches, what we found here now is the prime factorization of 40. What we do here to finish with is we now express 40 here as a product of prime factors. So therefore, 40 here is going to be equal to 2 times 2 times 2 times 5. And the reason we're using multiplication here is because we want to express it now as a product. So product here just means multiplication. Okay, so we do 2 times 2 times 2 again, and then we times it by 5. And what you should notice is obviously if you perform this multiplication here, 2 times 2 is 4, times it by 2, we get 8, and then 8 times 5 gives us 40. So to double check your answer, just perform the multiplication here and you should find that you get this number here that you started with. Okay? And then finally, sometimes you might get asked to express your prime factorization here in index form. So in that case now, what we want to do here is write this multiplication here as powers. So in that case then it would be 2 to the power of 3 here. So it's 2 times 2 times 2. That's 2 cubed, and then we times it by 5. That's the other way there that we can express the solution. Like I said, that's just index form there. Okay, it doesn't matter for this question, we're not asked to give it an index form, but just in case you are, that's how we do that as well. Okay, but there we have it, so that's the solution there to question 1. Moving on to question 2 now, where we just want to express 108 as a product of prime factors, giving our answer now in index form. So again, we just need a prime factor tree here to express 108 as a product of prime factors. We put 108 at the top of the tree here. 108. Now we do our 2 branches here from this number. So one branch to the left and one branch to the right. So 108 here, that's an even number, so I can divide it by 2. We get 2 here, and what do I times 2 by to get 108? Well, that must be 54. And what we do now is we check whether these numbers here are prime. Well, 2 is clearly prime, so we circle that. But 54 here, that's not prime, it's an even number, and it's not 2. Obviously 2 is the only even prime number. We know straight away that it won't be prime, so we do 2 more branches here, like so. Now we need 2 more numbers here, so a factor pair for 54. So again, because it's even, I'm just going to divide it by 2. So in this case here, I'm going to get 2 and 27. So again, just checking whether these numbers are prime here. 2 is prime, so we circle that. But 27 here is not prime, okay? Because I can express that here as a product of 3 and 9. 3 times 9 gives me 27. So now we just check whether these numbers here are prime. Well, 3 is a prime number, so we circle that. But 9 here is not a prime number because I can express that then as 3 times 3. We do 2 more branches here from 9. In that case, then my numbers here would be 3 and 3. And obviously we know 3 here is prime, we've already circled it, so we'll just circle these to finish with. And now because we can't do any more branches here, we know we found the prime factorization for 108. So now, if we just express 108 here as a product of prime factors, in that case then, 108. So now just be careful here, the answer needs to be in index form. We've got 2 times 2, so that's going to be 2 squared. We get 2 to the power of 2. Now we've got 3 times 3 times 3. We're going to times this now by 3 to the power of 3, or 3 cubed there. Okay, and there we have it. So that's the solution there to question 2. If we take a look here at question 3, we're asked to express 75 as a product of prime factors. So to do this here, we just use a prime factor tree. We place 75 at the very top. We do our 2 branches from this number, but 1 branch to the left, 1 branch to the right, and now we need a factor pair here for 75. So 2 numbers that we can times together to get 75. So I'm going to pick here 3 and 25. So 3 and 25. And what we do now is we check whether any of these numbers here are prime. In this case here, 3 is a prime number, it's only divisible by 1 in itself, so we circle this number. But 25 here, that's not prime, because we can express 25 as 5 times 5. We do 2 more branches here because it's not prime, like so. And then we pick that factor pair of 5 and 5. Okay, so now we check whether these numbers here are prime. Well, 5 is a prime number, so we circle 5. And because we now can't do any more branches here, we've already found the prime factorization for 75. So therefore, 75 is equal to 3 times 5 times 5. Or we could also express that here as 3 times 5 squared there. Okay, in index form. But there we have it, so that's the solution there to question 3. And finally then, if we take a look at the very last question here, question 4, where we want to express 240 as a product of prime factors, given our answer in index form. So the first thing that we do here is place 240 at the top of the prime factor tree, like so. So now we do 2 branches here from 240. We now need a factor pair here for 240. So I'm going to pick here 3 and 80. So 3 and 80. But you could also pick, for example, 2 and 120 there. That would also be fine. So now we check which of these numbers here is prime. Well, 3 is a prime number, so we circle 3. But 80 here, that's not a prime number. It's an even number, and it's not 2. Remember, 2 is the only even prime number. We do 2 branches here from 80. Like so. So now, I'm going to pick 8 and 10 here. So 8 and 10. Now we check whether these numbers here are prime. Well, 8's not a prime number, it's an even number, so it can't be prime here because the only even prime number is 2. Same for 10, that's also even. So in this case now we need 2 branches here for both of these numbers. So 2 branches from 8 and 2 branches from 10. Okay, so for 8 then, I'm going to pick 2 and 4 here as my factor pair. So 2 and 4. So 2 is a prime number, so we circle 2. But 4 is not prime, it's an even number, so we do 2 more branches here from 4. Like so. And in that case then, for 4 here, I'm going to pick 2 and 2. And 2 is obviously prime. We circle both of those. Okay. Going over now to the 10 here, I'm going to pick 2 and 5. So 2 and 5. Now we check whether these numbers here are prime. Well, 2 is a prime number, we've already circled that over here. And 5 is also prime, it's only divisible by 1 in itself. We circle 5 as well. And there we have it. There's no more branches that we can do here now, so we found the prime factorization for 240. In that case then, if we give the solution up here, so 240 is equal, what we'd have here is 2 times 2 times 2 times 2, times that by 3, and then times that by 5. But be careful here. We need to give the answer in index form. In this case, now it's going to be 2 to the power of 4. So 2 to the power of 4 here. We times that by 3. And then we times that by 5. Okay. And there we have it. That would be our solution there. So that's the prime factorization for 240 in index form. So that gives the solution there to question 4. And that brings the end of this video on finding prime factors of a number. In the next video, we're going to take a look at the highest common factor.